Hello students, in this video I will be going over hypothesis testing of a mean with sigma unknown and sigma known. These problems come from the last 3 pages of the hypothesis testing examples packet. On page 9 we'll do a hypothesis testing example where sigma is known, and on pages 10 and 11 we'll do examples where sigma is unknown. Please have your packet ready. The first example can be found on page 9. Sunspots have been observed for many centuries. Records of sunspots from ancient Persian and Chinese astronomers go back thousands of years. Some archaeologists think sunspot activity may somehow be related to prolonged periods of drought in the southwestern United States. Let X be a random variable representing the average number of sunspots observed in a 4-week period. A random sample of 40 such periods from Spanish colonial times gave the following data. There's a reference listed, and you can see the data right here. There's 40 pieces of data. The sample mean is 47. X bar is 47. Previous studies of sunspot activity during this period indicate that sigma is 35. Sigma is your population standard deviation, and it makes a big difference in the problem whether we know sigma or not. It is thought that for thousands of years, the mean number of sunspots per 4-week period was about mu equals 41. Sunspot activity above this level may or may not be linked to gradual climate change. Do the data indicate that the mean sunspot activity during the Spanish colonial period was higher than 41? Use alpha equals 0.05 for this problem. Because we know sigma in this problem, we are going to end up doing a z-test for this problem. And I always like to, when I'm doing hypothesis testing for a mean, list to the side sigma known z-test, so that way I don't forget to use the appropriate test for the problem. So let's go ahead and we can write in our claim and our hypotheses and our significance level. So the question asked is, do the data indicate the mean sunspot activity during Spanish colonial period was higher than 41? So our claim is that the mean is greater than 41. Our claim should always be in a symbolic form. For our hypotheses, we can list the null hypothesis. Always has an equal to sign, so it's mu, because we're talking about means, equals 41. The alternative hypothesis would be that mu is greater than 41. Note that the claim and the hypotheses should always have the same numbers listed. And then finally, our significance level, alpha, is given to us in this problem as 0.05. So we have all of our required information written, and now we can just go ahead and calculate our test statistic. We're going to use our calculator to do so. To do a z-test, we're going to go ahead and press stat over to tests, and option 1 is your z-test. We're going to put in statistics rather than type in all 40 data entries. And mu in this problem is given as 41. Our sigma is given as 35. The sample average is 47, sample mean. There were 40 pieces of data, n equals 40. And we're always going to use the same sign that we see in our alternative hypothesis, which in this case is greater than. Make sure that you don't just highlight it, but you press enter over it. And I'm going to go ahead and I'm going to press draw instead of calculate. So that way I get my picture. And you can see here that our z statistic is going to be 1.0842. Round it to at least 2 decimal places when you write it on your paper. And your p-value is 0.1391. Let's go ahead and write those on our paper. You can see I've copied the information from my calculator onto my paper, even labeling the diagram. Now, I have to decide whether to reject or fail to reject the null hypothesis. Using the p-value method, we are going to reject the null hypothesis if we have a p-value that is less than our alpha, which in this case is 0.05. And that region, alpha, 0.05, you can see falls right here. And we only reject if our p-value is less than that. So I always write, for p-value method, 0.1391, write our p-value on the left, write our alpha to the right, and then go ahead and compare them. And it says if P is high, null will fly. So we're going to fail to reject this way. Now, I also want to show you how to do this using the critical value method. So for the critical value method, we will be comparing the 1.08 test statistic with the critical value that gives us a region of 0.05 to the right. Page 2 of my packet, I am going to look in the right-tailed tests table for alpha is 0.05, and I'll see my critical value is 1.645. I can label that 1.645 on my graph right here. Now, I know any number for a right-tailed test that is at least as extreme as this critical value means that I should reject my null hypothesis. But we have 1.08 is not as extreme as 1.645. So once again, we're going to fail to reject your null hypothesis. Let's write our conclusion. Go to page 2 and look at the. So our original claim, it had a greater than sign. So that means it did not include equality because it was just a greater than sign. So we're going to follow that along. And then we failed to reject, so there's a no. So we're going to be using, there is not sufficient sample evidence to support the claim that, and then we'll type in our original claim. So we had no equality, and we failed to reject, leading us to our phrase we have here. So our conclusion is that there's not sufficient evidence to support the claim that the mean sunspot activity during the Spanish colonial period was higher than 41. The next example is from page 10 of the packet, and it's our first example where sigma is unknown. The drug 6-MP is used to treat leukemia. The following data represent the remission times in weeks for a random sample of 21 students using 6-MP. There's a reference listed, and then you have your 21 data values. The sample mean X bar is 17.1 weeks, with the sample standard deviation being approximately 10. Let X be a random variable representing the remission time in weeks for all patients using 6-MP. Assuming an X distribution is mound-shaped and symmetric. Previously used drug treatment had a mean remission time of 12.5 weeks. Do the data indicate the mean remission time for using 6-MP is different either way from 12.5 weeks? Use alpha equals 0.01. Once again, when I do a problem like this, I know it's important to know whether sigma is known or not. So I like to write that at the top of my paper. And if sigma is unknown, just like with confidence intervals, we're going to use t-test. For confidence intervals, we use t-interval. Here we're going to use t-test. So for this problem, I'm going to say that the claim is that the mean is equal to 12.5. You could also do this problem with the claim being not equal, means not equal to 12.5. It's going to just change your wording in the end conclusion. So our hypothesis will also be the mean is 12.5 because the hypothesis always has an equal to sign, the null hypothesis that is. The alternative hypothesis would be that the mean is not equal to 12.5. Make sure you have all the appropriate wording. And then our alpha given in the problem is 0.01. I'd like to note to you that on page 2 of this packet, all of your calculator skills for this unit are listed, and we're looking for a hypothesis test about a population mean when sigma is unknown. So we're going to be using stat test 2 t-test and then follow the process. So go ahead and press stat tests 2 on your calculator. We can just put in stats because they gave us summary information. Our mean mu is going to be 12.5. Our X bar is 17.1. Our sample standard deviation is 10 approximately. And there were 21 sample values. We're going to use a not equal to sign and get a two-tailed test for this one. And you can go ahead and press draw. And you should see our graph. You can ignore the box plot, but you can go ahead and copy this information onto your paper. T is 2.108 and P is 0.0478. You can see I've copied the information down that we found in our calculator. Now, I want you to note that I labeled it T. I expect that in your work that you label the correct test statistic. But also on page 2, our critical values table for common ones used only applied to z-scores. So we are going to find our answer for these sigma unknown ones using the p-value method. So for the p-value method, remember you're going to take the p-value you get and compare it to alpha for the problem. So our p-value is 0.048 and alpha for this problem is 0.01 and 0.048 is higher. And if p is high, the null will fly. So we're going to fail to reject. Graphically though, I can see this, but I can shade a region of 0.01 divided by 2 because we are in a two-tailed test. And you can see that the black shaded region is bigger, so it doesn't fit into our alpha region, so it is not as extreme. So now we can go ahead and we can write our conclusion sentence. Our original claim for this one did include equality, so we're going to say yes there. And then we failed to reject. So we're going to say there's not sufficient evidence to warrant the rejection of our claim. In conclusion, there's not sufficient evidence to warrant the rejection of the claim that the mean remission time using the drug MP6 is different from 12.5 weeks. Our last example is on page 11 of the packet. Coyotes. A random sample of 46 adult coyotes in a region north of northern Minnesota showed the average age to be X bar is 2.05 years with sample standard deviation of S equals 0.82 years based on information from the book Coyotes Biology, Behavior Management by M. Beckhoff, Academic Press. However, it is thought that the overall population mean age of coyotes is 1.75. Do the sample data indicate that coyotes in this region of northern Minnesota tend to live longer than the average of 1.75 years? Alpha is 0.01 for this problem. You can note here that sigma is unknown. You can see I've listed the claim as mu is greater than 1.75. The null hypothesis is mu is 1.75. The alternative hypothesis is mu is greater than 1.75. And our significance level is 0.01. I listed the important information to the side, and I determined I'll be using a t-test since sigma is unknown. Let's put this in our calculator. Select stat over to tests and select a t-test. Now we're going to use stats and we'll type in our mu as 1.75, our X bar as 2.05, standard deviation 0.82, and our N value for this problem is 46. Go ahead and you want to change the sign to greater than because that's what we have in our alternative hypothesis. Now go ahead and draw. You'll get t equals 2.4813 and your p-value is 0.0084. Copy that onto your sheet. I've copied down the information and now we need to determine whether to reject or fail to reject. So we'll write our p-value 0.008 on the left and then we'll write our alpha 0.01 on the right. And we can see that alpha is greater. So that means the p-value is low, then the null must go. So we're going to reject. Graphically, we can see that 0.01 would shade, this isn't to scale, but we would shade here, and we'd say this orange area is 0.01. Our p-value fits within the orange area. That means that we reject. Now let's write a conclusion sentence. Go to page 2 of your packet to access the flowchart. Our original claim had a greater than sign, so it did not include equality. And we rejected it. So we'll be going with the sample data support the claim and write our original claim. When we put it together in conclusion, we can say the sample data support the claim that coyotes in this northern region of Minnesota tend to live longer than 1.75 years.